properties of chlorine. Okay. Physical properties. It is a greenish yellow gas with characteristic pungent smell. It is toxic in nature. It is extremely poisonous. Okay, highly toxic in nature. It is moderately soluble in water. And its aqueous solution is known as chlorine water. Mind it, chlorine water is being used for sterilization of water and also is used for bleaching purpose. On cooling, aqueous solution of chlorine give yellow crystals of Cl2 8H2O. Please remember, this is for your entrance. When you finish, you please tell me.
Done, sir.
Okay. Suitor. I will go for chemical properties. Okay. So here I'll just mention a little bit extra than which is then in your book. Okay. Chlorine is very reactive and reacts with several আরে না এখন বসে নাই যা যা আটি আছে
এরপর ওষুধ পাওয়া যায় না এখানে মাছ নিয়ে যাবে ওষুধ
and metals মাকে বলে কাটিয়ে না 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 মেরাজ
অংশ পড়ে না এলা ঘরে সেন্ট করে
This is not there in your book, combustibility. Please remember that chlorine is neither inflammable, neither it burns nor it supports combustion. Chlorine neither burns or support combustion. Two. Reaction with water. In absence of sunlight, it reacts with water to form hydrochloric acid, HCl. কতদিন পরে আইছে তাই তো যাওয়ার ইচ্ছেই হইব and hypochlorous acid.
জল খাবে কি আছে
Hypochlorous acid. And hypochlorous acid. Okay. So H2O plus Cl2, it will give you HCl and HOCl. Okay. Hypochlorous hypochlorous acid gradually decomposes to liberate nascent oxygen. HOCl gives HCl and see, this is the reason for which chlorine water bleaches and chlorine water is found to be disinfectant. Municipal water is being purified by adding chlorine water. B. In presence of sunlight, chlorine displaces oxygen from water. See here, H2O plus Cl2, it will give you 4HCl plus O2. See, reaction with metals. Classified. Very reactive. I don't know this is given in your book. Metals like group 1, group 2, sorry, metals react with chlorine at room temperature to form respective metal chlorides. Okay. Suppose you have put sodium in a jar of chlorine, you'll find sodium is burning. Highly exothermic. So you will get here now 2NaCl. 2 potassium chlorine, it will give you 2KCl. If you have taken calcium, it will immediately burn to give you calcium chloride. B. Less reactive metals like copper, zinc, tin, iron, aluminium, etc. combine with chlorine when heated. Okay, so let me write it here. copper, Cl2 will give you CuCl2. Okay. ZnCl2. That's it. ওইটা রোমিং করতে হবে।
আপনি কি গুগল মিটে
গুগল মিটে করা যায়, জুম দিয়ে করা যায়। আমি তুই তো কি করে গুগল দিয়ে করবো?
গুগল মিটে করতে হবে 20 তারিখ থেকে। আর কিন্তু আমরা ভিডিও, আমরা প্রাইমারি সেকশন ভিডিও আর ওয়ার্কশিট
তুই
পাঠাচ্ছি।
কোন সময় তোর ক্লাস?
আমার তো 7:50
ওইখান দিয়ে হতে পারবে।
না, সামনের সপ্তাহে নাই, সামনের সপ্তাহে সব পড়া রেডি।
আচ্ছা।
এগুলো গুগল মিটে কি করে করতে লাগে, এরকম করে রাখতে লাগে।
এরকম লেখলে দেখবো হচ্ছে। তুই আমার ক্যামেরা দিয়ে করতে পারবি।
দেখে
ওই এই দুইটা কিনে এনে দিছে। এই আমার এইটা এটা এটা ক্যামেরাটা খুব ভালো। এখান থেকে করতে পারবে। আমার সকালে ক্লাস নাই, সকালে স্কুলে গিয়ে ক্লাস নেই।
আচ্ছা,
এটা তো জুমেই দিছে, জুম।
এটা কি কোচিনে পড়া?
হ্যাঁ,
কোচিনে পড়া?
হ্যাঁ, কোচিং আমারই ছাত্র।
অনেকগুলো একসাথে পড়ছে না?
হ্যাঁ, না এইখানে কতজন আছে? 12-13 জন হইব।
12।
Reaction with non-metals. All non-metals, including semi-metals, react with chlorine when heated. Okay, so let me write here 2 sulfur Cl2, you get down here S2Cl2. Please remember, dear, this is called sulfur monochloride. Now, if you have taken phosphorus, this is already you have done Cl2, it will give you phosphorus pentachloride. Okay, you put it. Suppose you have taken, these are non-metals. If I have taken, say, for if I have taken arsenic, and if I have taken this, arsenic is a semi-metal. Semi-metal. So if you heat it, you'll get now here 2S. Oh, sorry. 2AS. Arsenic triplet.
done, sir.
Okay. Now we'll go for wait, 1, 2, 3. Affinity for hydrogen means what? It reacts with hydrogen. Chlorine reacts with hydrogen in presence of diffuse sunlight. Diffuse sunlight means what? Ultraviolet light. Okay, so H2G Cl2G, it will give you HCl G. Chlorine has so much affinity for hydrogen, means they like hydrogen so much. It can even remove hydrogen even from hydrocarbon. That hydrocarbon means what? These are organic molecules. That we'll discuss later on. Huh? So I'll write down here C10H16. This is called terpene well. Terpene well, you know what from you'll get? You'll get it from the pine trees. Okay. So if you have reacted with chlorine, you'll find it has taken out all the hydrogen and carbon is precipitated. Okay, so you'll get now here 16 HCl. This is their inner form.
Done, sir.
Okay. Reaction with halides. Chlorine being more electronegative than bromine and iodine displaces them or oxidizes them from their corresponding acids and salts. See here. So I'll first try to make you understand, then only. Right, like see, this is chlorine atom. Chlorine atom. Chlorine molecule will break down to give you chlorine. Suppose it comes in, so right now here 2Cl. So what will happen? Chlorine will take the electron from the bromine. It will take it from bromine. Then what will happen now here? You will get here 2Cl minus and you get 2Br. Halogen atoms are not stable. So what it is going to form? You will get here now Br. So I'll write now here Cl2 will form 2 chlorine atom. It oxidizes bromide or iodide. Oxidation means what? Which will help the others to lose electron. So it helps bromide to lose electron and become bromine atom. So whether it is in acid or it is in a salt. So I'll write now here. This is our theory. Same thing is applicable for iodine also. So I'll write now here. Cl2 2HBr. It will give you what? 2HCl, because H is in HBr is H is H plus, Br is Br minus. So you'll get 2HCl plus bromine. Cl2 2HI. It will give you 2HCl plus I. Similarly, if I have taken here potassium bromide, it will give you 2 KCl plus Br. Cl2 plus 2 Ki, it will give you 2 KCl plus I.
Answer.
This number I forgot. You put the number. Reaction with ammonia. This we have already done there, but still I do. Reaction with ammonia. So you know in presence of excess of chlorine. Okay. So I'll write now here NH3 3Cl2. You will get here NCl3 and CHCl. This is called nitrogen trichloride. Okay. Nitrogen trichloride. Please remember, if you go for NF3, NCl3, NBr3, Ni3, only NF3 is stable. Others are not stable and they are explosive in nature. Okay, this is for your entry. Out of NF3, NCl3, NBr3, and Ni3. Only NF3 is stable, while others are not stable and explosive in nature.
Done, sir.
Wow. Oh wait, let me put some ink. It dries up, na? Okay. So now we'll go for excess. See here, why do you call it excess of chlorine? 1:3. So in presence of excess of ammonia. So I have showed you how to do it. Remember, 2NH3, 3 chlorine, it will give you N2 plus 6 HCl. See, this is acidic, this is basic. So what will happen now? This HCl will now react with the rest amount of the ammonia. So I'll write now here NH4Cl. How many are there? 6. So I will multiply it by 6. All right. You can write 6, no problem. 6 here. So see, 6 plus 2, 8. 3Cl2. It gives you both the reactions are important, especially this is important. বাইরে গেলে না অন করে ও বানিয়ে দিয়ে বুঝি লাগবে
এটা আমাকে শিখিয়েছে দাদা যদি ধীরে ধীরে দেখলি না ফিল্টারের জল তো কম আছে ওই জল ফুটিয়ে চান করবি না আমার তোমার যাতে চিকমিষ্টা বলে ডিজাইন করেছে
ঠিক নাকি? এটা মরিয়ে যখন যারা চাইবো এ থাকবো এ থাকতো না, এখানে এমএলএ তো আর ঠিক করতে পারে না, মরিয়ে ঠিক করে আর আচ্ছা। নেক্সট ইজ reaction with alkali. Reaction with alkali. This is also very important for exam. Right now here, cold and dilute. So let me write here sodium hydroxide and chlorine. It will give you NaCl, NaOCl, H2O. This is called sodium hypochlorite. Sodium hypochlorite. CHLORITE. Sodium hypochlorite. Now I let show you what is the difference between sodium chloride and sodium hypochlorite. This is for your only understanding. See, sodium chloride dissociates to give you Na plus and Cl. NaOCl dissociates to give you very interesting. Oxygen is more electronegative than chlorine. So you will get now here Cl plus. Because of that, this reagent is very, very important. See, Cl minus is called what? We call it chloride. Then what is you call it Cl plus? We call it chloronium ion. Okay, now B. Hot and concentrated. See here. This is 6NaOH. See, concentrated means more. Here it is dilute means less. Plus 3Cl2. It gives you 5NaCl, NaClO3, and H2O. This is called sodium chloride. This is called sodium chloride.
Done, sir.
Okay. Now we'll do another important reaction. Both these reactions are important. Now reaction with slacked lime. We should know this term slacked lime. I have written intentionally. Okay. Slacked lime is calcium hydroxide, which generally take with pan. Shown mo? This is the okay. When chlorine is mixed thoroughly with slacked lime, form bleaching powder. See, it is going to form what? CaOCl twice plus CaCl2 plus 2H2O. Actually, this is the bleaching powder, dear. This is bleaching powder. But yesterday only I told you, given you another formula, CaClOCl. So I have not told you a lie or wrong thing. I'll show you now how it is. Bleaching powder. So here, see, this is solid. This is solid. This is solid. So when you carry out the reaction, 100% of the calcium hydroxide does not react. And it is difficult to separate this solid from other two solids. So what about the bleaching powder we get? No, it contains all three of them. Okay. So what is the composition of bleaching powder that you buy from the market? Composition of bleaching powder is, first we will write the original compound. Then I'll put a full stop. This. This. And the water does not go out. Water is being absorbed. So the market, whatever the bleaching powder you get, it is this is the composition of bleaching powder. Suppose 100% of this one has reacted. This will not be there. So what you will get in the mixture? COCl2 plus CaCl2. See here, you have 2 calcium, so I'll write here 1. You have 2 chloride, so I'll write to 1. You have 2 OCl, so I write to 1. So this is the proportion. Because of that, we write the bleaching powder with the formula is this. But actually, bleaching powder is a mixture of calcium oxychloride and calcium chloride. All right. So whatever the formula that I have written is not wrong. All these 3 reactions are very, very important for you in the exam.
Done, sir.
Okay. Now we'll go for oxidation reaction of chlorine. Okay. So now we'll go for oxidation reaction of chlorine. Chlorine oxidizes only in presence of moisture or in aqueous solution. Why? This is because chlorine liberates nascent oxygen from water. This is because chlorine liberates nascent oxygen from water. Huh? This is the one which oxidizes. So we'll do some example first. You write an example is very easy. You can do it.
Done, sir.
Okay. So now we'll do some example. It oxidizes sulfur dioxide to H2SO4. See, it's very easy. We'll write now. First, this equation will write H2O Cl2 HCl plus nothing. See here, SO2 plus O. What it will give us? It will give you SO. But you know, SO3 when it comes in contact with water, what does it give? Huh? Okay. SO3 plus H2O is what? H2SO4. All right. All right. So let me finish. I write it in one step. H2O. So what will write now here? See. How many moles of the water? 2H2O. SO2. H2SO4. 2HCl. Okay. Next. It oxidizes sulfide to sulfate. These equations are not difficult. See here. H2O plus Cl2 is equal to HCl plus O. See here. SO3 2 minus. It will give you what? SO4 2 minus. So you write here now oxygen 3 plus 1 4. The depth. So now you add it. ও তুই কি শনিবারে খাস না? হ্যাঁ? আমি আনলাম ব্ল্যাক ফরেস্ট কেক। পড়াতে খুব ভালো bakery. It's one of the best bakery. না এটা তো গেছি পুলি বাজারে লিখেছি। তুই যাওয়ার পরে লিখেছি হয়েছে নাকি? আগে আরবির কিনার একটা দোকান আছে ওইখানে। আরবি না আরবি এখন ভালো না।
Done, sir.
Okay. So now then it oxidizes ferric sulfate. Sorry, not ferric, ferrous sulfate. Ferrous sulfate. FeSO4 to ferric sulfate. In presence of the power can write it like this. H2O equal to 2HCl plus 4. So now we'll write here ferrous sulfate. Here we'll write ferric. Okay, this is the formula of ferrous ferric sulfate. So now see here, 2 irons. So let me write 2 here. Now here you have 2 sulfate, here you have 3. So sulfate 3 cannot be produced. So you have to write here H2. So iron is balanced, sulfate is balanced. Which is not balanced? Hydrogen. Which branch. So it is H2. This water and this water get cancelled. Okay. Plus Cl. আছে
Yes, sir.
Right. Now we'll go for bleaching action of chlorine. Hello. Therefore, তুই কই আছো জানার লেগে ফোন শিলং হ্যাঁ ও আচ্ছা 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 ঠিক হোটেলে পড়ছে ব্লিচিং bleaching action of chlorine. Chlorine is a strong bleaching agent. It bleaches only in presence of moisture or in aqueous solution. It bleaches by oxidation. The nascent chlorine it liberates from water. Bleaches the color. So right now here, this equation already we have written 2HCl plus nascent oxygen. Then colored substance plus oxygen, it will give you colorless substance. So this is the equation of bleaching. Okay, now. Okay, you write. Then after that I'll explain to you.
Done, sir.
See now, when we have done the bleaching action of sulfur dioxide, I told you it is temporary. Why? In sulfur dioxide, colored substance is being bleached by hydrogen. So this hydrogen, it reacts with the oxygen of the atmosphere, and again the color reappears. But in case of chlorine, bleaching action is permanent. Why? Because it is bleached by the oxygen. In our atmosphere, you do not have any hydrogen. So this oxygen never goes and the color does never reappears. So this is important for your exam and so for your knowledge. So we'll write down here. Bleaching action of chlorine is permanent. Why? This is because the nascent oxygen which bleaches the color does not go out due to the absence of hydrogen in the atmosphere. So this oxygen does not go, and that makes it permanent. So if you want to bleach anything for good, you want to make it permanent bleaching, then you have to go for chlorine water. Okay. So what are the substance we use it for long time? Once you bleach, you don't want that color should go. So what are the substances we use it? Thus, it is used to bleach what? Cloth, textiles. Okay. So if you have made the cotton textile, when you get the cotton from the field, then you spun it into thread, then you go for weaving it, and you have made the cloth. By this process, it gets very dirty. It becomes yellow. So you have to make it super white. So this cloth is being dipped in chlorine water. Once you dip it in chlorine water, then it becomes perfectly white. After that, you can use it as white, or you can again dye it or print it. Okay. Second, pepper. The pepper we get it from the wood and bamboo. These are brown in color. So this pepper pulp is bleached into white, and after that you get that white pepper. Okay. Then leather. It is from hides and skin that we get leather. That is also brown and dirty in color. That is also being bleached, and after that the color is applied on. Okay. Now, what are the differences? Okay, we'll write now. Similarity and differences between bleaching action of sulfur dioxide and chlorine. See, these are totally opposite of each other, but one similarity it has. This is again for your entrance exam. Similarity. What is this? both sulfur dioxide and chlorine bleaches only in presence of moisture or water. Differences: sulfur dioxide and chlorine. It bleaches by reduction. See here, H2O, sulfur dioxide, H2SO4 plus 2 hydrogen. So this is the one which bleaches. It bleaches by oxidation. So it is H2O, Cl2, 2HCl. This is by oxidation. Second, it is temporary. It is permanent. So these are the two differences. What are the things we bleach here? We bleach food items, which is we immediately consume it. We bleach maida, flour, we bleach fruit juice, we bleach sugar, and this is permanent. So the thing which you use it for whole life or long time, we bleach, like textiles, paper, leather, etc. So with this, I finish your class today.
Done, sir.
Okay then.
Bye, sir.